Hello, my beautiful computer science students. Welcome to another lesson in Unit 6, where we are going to go over common algorithms for arrays in this lesson. So there's going to be 7 total common algorithms we'll cover in this video, but believe it or not, there's a lot more. So we'll cover kind of the main 7 from the AP CSA CED, but there are a couple that I don't cover in this video. We will be covering those ones in the homework and review assignments that we have in class. But let's get into common algorithms. So what do we mean by common algorithms here? Well, when we have an array of data, there are some common tasks we end up performing with an array of data. So common, and we use them so often that we call them common algorithms. So the algorithms that we're going to kind of go through step by step are a snapshot of what those tasks end up being. You'll want to make sure that you understand how these algorithms accomplish their task. So what I'm going to do is give you a piece of instruction telling you to write a method in order to do this with the array. And you're going to use one of those common algorithms to accomplish that task. Now, do you have to memorize these? No. Okay. You don't have to memorize them line for line, but you'll use them so often in your homework projects and even beyond this course that you'll end up kind of memorizing how they work anyway. Okay. And you'll start to see kind of a pattern emerge throughout all of these algorithms. And I'm going to help take you through and explain what some of those patterns are and just how you can more easily accomplish some of the goals that you need to with arrays. So let's get into the first one. Okay? The first common algorithm is determining a min or a max value from an array of integers. Okay, so you'll see the instructions off to the left of the screen there. It says write a method called max that returns the index of the largest number, the maximum, in a passed array of integers. And the code that you see written here on the screen is very true to what you'll see on the AP exam in terms of how they phrase the return statement and how they describe the precondition. So this describes the method as returns the index of the largest number. Okay, so wherever the largest number is, you're going to return the index. And the precondition is that you're passed a non-empty array of integers. Now, the reason we have that precondition is because we can assume that this is true and we don't have to check for it. Okay, so when you go to write the code will not work on an array of integers that hasn't been filled yet. Okay, so you're assuming that you have a non-empty set of arrays, because if the array hasn't been filled yet, you'll get an index out of bounds issue right out of the gate. So you don't have to check for this, okay, is what the precondition means. You can assume that you'll be passed an array of a non-empty array of integers. Okay. So a lot of the times you'll want to check that precondition on the AP exam to see, okay, what do I not have to check, or what maybe do I need to check for? This time we don't have to check for it. So what do we want to do? Well, let's start off with a little bit of, not pseudocode necessarily, but just think about steps that we have to do. First, we want to keep track of the largest element, okay? And we also need to keep track of the index of the largest element. So we need to keep track of those two things in this method. So keeping track of those two things. Once we have variables to keep track of those two things, then we want to traverse the array. Okay? And we've already gone over how we traverse arrays, so we'll use that code to traverse the array. We'll check to see if the current element in our loop is bigger than the largest element we have recorded with our variable that we're keeping track of. And if it is, then we have a new largest element and index of the largest element. Okay? So let's start off with the header here. Okay, it's a method. We'll make it static, public static. It's going to return an int, the index of the largest element. We're going to call it max, and it's passed an array of integers. Okay, so that's going to be our method header there. From there, number 1 and number 2 on my list says I need to keep track of the largest element and the index of the largest element. Now, What we can do is assume that the first element in the array of integers is the largest. So that's why I have max equal to ARR0, because that's taking the first element in the list and saying, okay, we're going to call that the max. And then the max index, we're going to call 0 since it's the first element in the list. So those are going to be the two variables, keeping track of the largest element and keeping track of the largest index there. Now we're going to traverse through the array. You'll notice here that I start at I equals 1 because I've already assumed that the first element in my array is my max. So if I assume the first element in the array is my max, I want to start with my second element at index 1 to check to see if that's larger or smaller than the first element. So I start at I equals 0. Not a big deal if you start at I equals 0. I just start at I equals 1 for this algorithm here. So this is how I'm going to be able to traverse the array. And I'm going to go through the entire length of the array since I have ARR.length. And then here's my check. So I check to see if max, which remember is the variable that's keeping track of my largest element, if my max is less than the element that I'm currently at in my list, then that means that this is the bigger one, right? And if that's the bigger one, then I want to assign that element to be my new max and that index to be my new max index. Okay. And then from there, at the end, I just return max index. Okay. Now, there are some changes you can make to this algorithm and still have it accomplish the same goal. Okay, for instance, we technically don't need this variable here. As long as we know where the max index is and we keep track of that, we know where the max element is. Okay, so if you can see it, we technically don't need that. We can replace this with like an ARR max index. And then that eliminates basically 2 lines of code if we do that. Okay, so there are changes we can make throughout all of these algorithms to even have them just work the same way. Is this more efficient? No, that's something for other computer scientists to determine. We don't care about efficiency necessarily in this class, but we do want to recognize when 2 pieces of code segments do the same thing. And in this case, we could eliminate that variable and have it do the same thing. You'll notice small things like that throughout all of these algorithms, and that's a good thing that you're starting to recognize that. Okay. So determine a min or a max, and you can see how we can slightly change this so that we would find a minimum in an array of integers. Okay. Let's move on to the second algorithm. So this is compute a sum from an array of integers. And if I'm remembering correctly, I think we did this in class earlier as well. So we'll just kind of repeat it here because it is a very common algorithm. If we have an array of integers, we want to be able to compute a sum. Okay. So what are the steps? Well, we need a variable to keep track of the sum. We need to traverse the array, add the current element to the sum. We don't have to check anything because we're adding everything to the sum, every element to the sum. So we just add the current element to the sum, and then we return the sum. Okay. Pretty straightforward algorithm here. So we'll write our method header, public static int sum, and I'm passed a non-empty array of integers. I need a variable to keep track of my sum, set it equal to 0. I'm going to traverse my array with my familiar for loop. And then I want to add the current element, so that's your ARRI. Add the current element and accumulate it to sum. Okay, so remember we want to accumulate it to sum, that plus equals, and then we just return the sum. Okay. Very common algorithm to do. Okay, very straightforward. So going back to the question, do you have to memorize this? Not necessarily, but you got to know how it works, right? So if I ask you to compute a sum from an array of integers, you should be able to do that for me. Okay. Algorithm 3. Okay. It says determine if at least one element has a particular property. Okay. So determining if at least one element in your array has some particular property that you are looking for. So these instructions say write a method called any negatives that is past an array of integer values and will return true if there is at least one negative. Okay, so we're going to traverse the array, and if we find a negative, good, we're done. We want to return true because we found at least one negative value. So our steps are just to traverse the array. We don't need a variable to keep track of anything. We are looking through the array. We are checking if the current element is negative, and if it is, we just return true because we found it. Okay, at least one element has that property. If we go through the whole array and we don't find a negative, we want to return false. So we're going to return false after the loop, meaning we looped through everything, we weren't able to find a negative, so we return false. So here's going to be our method header. We're returning a Boolean, so we have that Boolean return type, and we accept an array of integers. Traverse the array in our usual fashion. Check to see if the current element, again, when we say current element, we talk about what that element is every time we loop through. If it's negative, we return true. And if we go through the entire for loop and we never end up tripping this, that means that there's no negative, so we want our return statement outside of our for loop to return false because we never found a negative. Good deal. Okay. Algorithm 4, determine if all elements have a particular property. So this one kind of goes hand in hand with the other one. We're actually going to just change the algorithm for algorithm 3 slightly. Okay, basically just switch two things, because now we want to write a method called negative array that again is past an array of integers and returns true if all of them are negative. Okay, not just if one, which was the last one, but if all of them are negative. So these are our steps, and you'll see it's very similar to our last set of steps. We traverse the array. This time we check if the current element is positive. Okay? And if it is positive, we return false. Okay, this is supposed to say positive. Since a positive was found, we return false. We return true after the loop if a positive was never found. Sorry. It was so similar to the last algorithm, I forgot to change those two words. Okay. Very similar. So almost I think it is the exact same method header except for the name of the method. Traverse the array. This time we're checking to see if it's positive instead of negative. So small change from the last one. And if it is positive, we return false. Okay, because if one element is positive, we return false because not all of them are negative. Okay. If we go through the whole array and we don't find a single positive, we return true, meaning that all of the integers were negative. Okay. And that's just how I wrote that algorithm. Okay. There could be several other ways to write the same algorithm and have it accomplish the same thing. Okay. All right. We're going to move on to algorithm number 5 next. Determine the number of elements meeting a specific criteria. Okay, and this could be any criteria. In this example, I want you to write a method called 3 multiples that returns the number of elements in an array that are evenly divisible by 3. So that's the specific criteria that we are looking at here. So our steps for this algorithm: have a variable to keep track of the count. We want to then traverse through the array, check if the current element is evenly divisible by 3, and if it is, we want to add 1 to count. Okay. And then at the very end, we return count, because that's going to be how many elements in the array are evenly divisible by 3. Okay. So here is our method header. I'm returning an int because it's the count of how many elements are evenly divisible by 3. I make a variable to keep track of the count. I traverse my array. I have a check. Is the current element evenly divisible by 3? So if the current element mod 3, if the remainder is 0, then that means that it's evenly divisible by 3. And I'm going to add 1 to count. And at the very end, I return that count. Algorithm number 5. And this could be any specific criteria. You know, is it an even number? You could have an array of strings. You know, does the first letter start with S, right? Any criteria, loop through the array, traverse the array, and you can count it up with that if statement inside that loop. Okay, before we get to the last two algorithms, I want to talk about the swapping algorithm. Okay, so the swapping algorithm, we'll see it a little bit in this unit, but it's more common in sorting arrays, which we're going to get to in Unit 7, in the next unit. But the swapping algorithm is something that, again, do you have to have it memorized? Well, probably. You'll use it so often. Okay, when you want to swap two elements of the array, so you have an array and you just want to swap their positions. Okay. What do? Well, there's 3 steps to this algorithm. First, you store the value of whatever your first element is in a temporary variable. Next, you assign the value of the second element to the first element. Okay. So the first element here, you need a visual. The first element here gets put into a temporary variable. The second element is copied to the first, so that basically at this point in the algorithm, you have 2 of the same numbers or words, whatever is in your array. You have 2 of the same values in your array. And then the third step, the temporary variable gets put in the second element. Okay? And that's how you can swap these two elements, whatever they are. So here's a small example using strings. So I have a string of animals. Write code to swap goat and duck. Okay. So 0, 1, 2, 3, 4. So I want to swap goat and duck. Now when I say I want to swap them, I want to put it so that the word duck is here and the word goat is here. Okay. So you see how I can't just say animals 1 equals animals 4, right? That's not going to be good enough, okay? Because if I do that, that says, okay, take this and make that duck. And then when I go to make this goat, how do I make that goat, okay? I can't because I already lost goat. All right, goat is already gone. So that's why I introduced that temporary variable in my algorithm to store whatever this value is. Then I can make a copy of duck over. And then because I have that temporary variable, then I can put that in place of duck. Okay. So that's what's going to happen. I'm going to have a temporary variable. You can just call it temp, whatever, equals to animals 1. So temp is going to be equal to goat. Then I take animals 4 and I put it in animals 1. Okay. So that's when I make the copy. So now at this point you can see in my array of strings that I have duck in 2 places. And then I have my last step of my swapping algorithm, and that's to put my temp in place of 4. So since goat was stored in my temp, it goes in place of duck. Okay. So now both goat and duck got erased and swapped. And that's what my array of strings would look like now. Okay? Swapping algorithm. You'll need to know it. I've had students in the past, if you have a hard time kind of memorizing the steps, they know to start off with temp and then the first element. The first element goes here, second element goes here, and then it ends with temp. So it starts with temp, the variable starts with temp and ends with temp, and then it has kind of this chain effect inside the swapping algorithm. I don't know, a few students have said that helps them kind of memorize it, so if it helps you, go for it. But that's your swapping algorithm. And we're going to use it in these last 2 algorithms for arrays. Okay. Algorithm 6, so you have to know how to shift or rotate elements left or right. Okay, so shift, so if you think of an array, shifting everything, like if I have 6, 5, 3, and 2, if I want to shift to the left, that means I want to shift everything over to the left 1 and then move the 6 back at the end. Okay, so this would be, the new one would be 5, 3, 2, and then 6 would be at the end. So that would be what we call a shift to the left or a rotate to the left. And you can do the same thing to the right as well. Okay, so that's what we're going to write a method doing. We're going to write a method called shift left. It's going to take an array of integers and shift all the elements to the left. The element at the beginning of the array should move to the end, like we did in our example here. 6 was at the beginning, and now 6 is at the end. Okay, so you can see how in this algorithm we're going to have to make some swaps. Okay, some elements are shifting positions, and we have to make some swaps because of that. So here's the steps for our algorithm. We're going to use a temp variable to hold the first element. That's going to be step 1 in our method. Then we're going to traverse through the array, and we're going to watch the boundaries on this. I'll show you why. We're going to traverse through the array, and we're going to move the next element over to the right. Okay, so again, if I have 6, 5, 3, and 2, okay, 6 is going to be stored in a temporary array, and the first time through my loop, I'm going to have 5 get shifted over to this position. Okay, get copied over to that position. The next time through the array, I'm going to have 3 get copied to this position. And then I'm going to have 2 get copied over to this position, so on and so forth. Okay, so I'm going to have everything shift over, move the next element over to the, that should be over to the left because I'm shifting to the left. Yikes. And then make the last element of the array equal to the temp. Since I stored that 6 in a temporary variable, that's going to be my last step, is to move it over to the temp one. Okay, so what does that look like as code? So public static void, shift left, perfect. I'm void because I'm not returning anything here. Okay, I'm shifting the elements in my array, and remember that changes to the array are preserved, because they work like references. So I pass it an array, I change it, and then any changes made to this array are also made to the original array that was passed to it, okay, in our argument. So that's why I'm not returning a new array. Okay? I'm not returning anything. I'm just making changes to the array and then calling it a day. So it's a void because I'm not returning anything here. So step 1, I use a temp to hold the first element. Perfect. Then I'm going to traverse the array watching boundaries. So you'll notice how I'll start at I equals 0, and then I have this arr.length minus 1. Okay, and that's the first time this is popping up in our algorithm. So why do I have that in there? Well, inside the traversal, I want to move the next element over to the left. Sorry, remember I misspoke on this. I want to move the next element over to the left, so that 6, 5, 3, and 2. Okay, so if 0, this is my current index as I move through my array. This is going to be the index I start at, 0. 0 plus 1 is index 1. I want to take this value and move it over to this value. Okay. Next time through the array, I is going to be 1. 1 plus 1 is 2. So I'm going to take the element at 2 and move it over to index I. Okay. I'm going to keep doing that. Okay, but I want to end. I don't want my I to go to my last index, right? So if this is index 3, and I try to go to 3 plus 1, which is index 4, I don't have an index 4. Okay, so I don't want any out of boundary issues. I don't have an index 4. So that's why we have to go to length minus 1. Okay, I want the second to last element to be the last thing I go through, because the 2 is going to get copied over, and then I want it to stop. So at the end of this loop, it'll look like 5, 3, 2, 2 when that loop is done. Okay, the 5 got copied over, the 3 got copied over, the 2 got copied over, and then my last step is the step 4. Make the last element equal to the temp, because the temp held my 6. And so the last element, to access the last index, Remember, I use arr.length minus 1. That's going to be the last index, and that's going to be equal to my temp. That's a fun one. Okay. And I want you to notice what I did with that algorithm. I used an example, right? Throughout the whole thing, I wrote this example. Ooh, and actually now I'm realizing I wrote it, shucks, I wrote it behind my picture on the, myself on the screen. I'm so sorry about that. I sometimes forget that my face covers part of the screen. Yeah, I'm sorry about that. But I used this example throughout. And the way I did it, I said, okay, this is our temp. Now hopefully you can see it. This is my temp. Okay. I store my temp, my first element in my temp, and then I move my 5 over, move my 3 over, move my 2 over. That's what that loop did. Oops, excuse me, 5, 3, 2, 2. That's what my loop did. And then my temp went back to this right here. But the point I was making, I'm using this example for this algorithm to help me understand it better. And sometimes, especially on the AP exam, if you were to see a new algorithm and you're like, wow, I'm really not sure what this does, use an example, like a small example like this, a smaller array, and trace through and see what it's doing to that array. See how it's manipulating it. Because that is a common question on the AP exam is, what is this code doing, right? What is this code doing? And if it's the first time you're seeing that code, well, you might need to use an example like this to kind of move through it. Okay. All right. Last one. Reverse the order of the elements. This is a fun one, okay? Write a method called reverse that takes an array of integers and reverses the contents of the array. For example, if our array is 3, 6, 7, 10, the reversed array would be 10, 7, 6, 3. Okay. Boop. And I actually have an example there that's not covered by my face. So again, sorry about that. What are the steps? First, we want to traverse the beginning half of the array. Find the corresponding index in the end half of the array and use the swapping algorithm to swap the two elements. Okay, what does that mean, Mrs. Goldschmidt? Okay, so let me take you through the example first before I show you the code for this, okay? So if I have my example 3, 6, and I won't write this behind my face this time. I start at the beginning of the array, and I want to find the corresponding index that I'm going to swap it at the second half of the array, which is going to be this one right here. And I want to swap them. So the first time through the array, I want to swap those two pieces. The next time I increase I by 1, and I find the second to the last element, and I want to swap those. And I only want to go through half of the array because once I get to the halfway point, my array has been swapped. So I don't want to keep going and traverse through the whole array. I want to stop at the halfway point. Okay. Now, if you have an even amount of elements, in your array, like this right here, you know the exact stopping point, the halfway point. This also works if you don't have an even amount, like let's say you have 5, okay? You still want to swap, okay? You swap the 3 with the 10, swap the 6 with the 6 with the 8, and you just leave the 7 where it is, and you've reversed the array, right? Okay, so this works with even number of elements or an odd number of elements, okay? You just want to go through half of the array, switch the first with the last, and then move in 1, move in 1, okay? Move in 1, move in 1. So no matter how long your array is, you keep moving in on each side until you get to the halfway point, and then everything's been swapped. Okay. Hopefully that makes sense, because we always want to try to understand the algorithm that we're writing before we actually start writing the code. So that's how we reverse the elements. So here's the code for it. It's void because we're manipulating the array again. So changes to the array are preserved. We don't need to return a new array or anything like that. we're going to traverse through the beginning half of the array. And so this is arr.length divided by 2. So this is integer division, remember. So if I have an array length of 4, this is going to be 2. So I is going to go through 0 and 1 and up to, but not including the second element. So that means, like in this example, I would only go through I equals 0 and I equals 1 to swap those elements, and then I've reached the middle. Okay. With our odd example that we also did, remember that this is also 2. So if I have an odd number of elements, that middle index at index 2 will still not be touched because of integer division. Okay? So this is how I traverse through just the beginning half of my array. Next, I want to find, so I have index 0. 1, 2, 3. If I look over at my example here, I have index 0, that's I equals 0. Now I say I want to find the corresponding element in the end half, which when I is 0, I want the last index. So how I find the element at the end half, I'm going to have a new variable called middle end. I don't know why I called it that, but that's what it is. Where it takes the length of the array, it takes the last index minus 1, right? So if my array length is 4, my last index is 3, and then I subtract I in here. Okay, I throw that subtract I in because as I moves in, as I becomes 1, I also want my middle end to move in 1. Okay, as this moves in 1, this moves in 1. So that I that increments on this side, that I is also going to decrement the middle end on that side. Okay, so right now when I is 0, my last index is just 3. Okay, once I have my I, which is my beginning, and my middle end, that's going to be my last one. Okay, then I want to swap them, and that's where the swapping algorithm comes into play. Okay, I start with temp and I store. Ooh, excuse me. This is supposed to be ARR. Okay. I have my temp and I store that first element. Okay. I bet I made this list for all of them. Of course. Oh, Mrs. Goldschmidt. Those should be ARR for all of them because I was past ARR right here. Okay, so I have to have it be the same name. So I have my first element in my temp, and then I replace that first element with my middle end variable, wherever that location is. And then the last piece is, yes, I am going to change this every time. This is annoying the heck out of me. ARR. There we go. That's my swapping algorithm. These 3 lines right here, this is my swapping algorithm that we went over earlier. Okay, and I swap them. Okay, and by the end of that for loop, the order of the array will be switched. All right. And I think that brings us to the end here. Yes, it is. Yeah, 7 algorithms. You'll use them enough. You'll probably want to remember how they work. But we are going to go over a couple more of these algorithms in the homework and in our review assignment later on. So enjoy this. All right. Thank you guys so much for sticking around and working through these with me. And I will see you next time.